when we are getting this, when x should be when x is less than 1. Okay, that means we need to take the intersection of these two. That means we need to take the intersection of these two. X belongs to minus infinity to 0, minus infinity to 0 we are getting in the first one, but when x is less than 1, that we are getting in the first case. That means we'll have to take the intersection of these two. So intersection of these two, how we can take? So we'll have to draw a number line. We'll have to draw minus infinity 0, minus infinity 0 will be here somewhere, 1 will be greater than 1, and then plus infinity. So x belongs to minus infinity to 0, and 0 is there, it is containing 0. That means we'll have to draw a dot here that shows that we are including 0 also. X is less than 1. Less than 1 means we are not including 1. Okay, not equal to 1. X is less than 1, that means we are not including. That's why we are making a arrow here. That means that represent we are not including this one. So here the common part is nothing but the common part that is in both. Okay, that is from minus infinity to 0. That means we can say that x belongs to minus infinity to 0, close interval. That is the answer in the first case. Okay, the answer in the first case. Minus 2. But when we are getting this x belongs to minus infinity to minus 2, when we are getting when x is from 1 to 2, minus infinity to minus 2. So here x belongs to minus infinity to minus 2. But when x is greater than equal to 1 less than 2. Okay, that means we'll have to take the intersection of these two. Okay, so we can take the intersection of this thing. So for taking intersection, we have to draw a number line, that is minus infinity minus 2, minus infinity minus 2 will be here somewhere, and then 1 and 2. So 1 will be here somewhere, 2 will be here, and plus infinity will be here. So x belongs to from minus infinity to 2, that is from minus infinity to minus 2, minus infinity to minus 2, closed interval. That means we need to include, and for including we will draw a dot. That means we are including this minus 2 also. X from 1 to 2, we need to include 1 not 2, that is 1 to 2, from 1 to 2, like this, 1 to 2. So here if you'll see, there is no intersection, no common between the both, no common values. So we can say that x belongs to 5 here in the second case. X belongs to 5, that is no x in the second case, no x in the second case, and that is the answer in the second case. When x is greater than equal to 2 less than 3. Okay, when x is greater than equal to 2 less than 3. So x belongs to, what we are getting is 6 to infinity, close interval, 6 to infinity. But when x is greater than equal to 2 less than 3, when x is greater than equal to 2 less than 3, greater than equal to 2 less than 3, that means we need to take the intersection here. So how we can take the intersection? By drawing a number line, 6 to infinity. So 6 will be here somewhere, 2 and 3, this 2 and this 3, this 2 will be here somewhere, 3 will be here somewhere. 6 to infinity, that means all the values from 6 to infinity, closed interval is there, that means we need to include 6 also, that's why we are keeping a dot here. And 6 to infinity, that means this side, 2 to 3, all the values from 2 to 3. 2 to 3 means we need to include 2 greater than equal to, that's why we are including 2, and 3 we cannot include 3, that means we will like this. So here that we can see that clearly there is no common. So we can see that here x belongs to 5, or no x here. Okay, we can say that, and this is the answer in the third case. Now we are going to take the union of all the answers. Okay, so take union of first, second, third and fourth. Okay, so what is the first, second and third and fourth? That is nothing but, first if we move towards the first answer is nothing but minus infinity to 0 close interval, minus infinity to 0 close interval, that is x belongs to minus infinity to 0 close interval. This is the first answer. What is the answer in the second case? Second answer is nothing but no x, second is x belongs to 5, no x, and third if we move towards the third, so answer in the third case is nothing but no x, there is no x belongs to 5 in the third case also. And fourth case answer, what is the answer in the fourth case? X belongs to 4 to infinity, that is nothing but x belongs to close interval 4 to infinity, that is the answer in the fourth case. So we need to take the union here, so that is nothing but we can draw the number line, that is minus infinity, that is plus infinity, minus infinity to 0, minus infinity and 0, so 0 will be here somewhere, and second and third are useless. 4 to infinity, that is 4, so minus infinity to 0, that means from here to here close interval on the 0, and 4 to infinity, that is nothing but 4 to infinity like this, and we are taking union, so we'll have to combine both the results. So we can combine x belongs to minus infinity to 0 close interval union 4 to plus infinity, that is our answer, that is our final answer. We can say that is our final answer. And if we move towards the options, so options we can see minus infinity to 0 union 4 to infinity, that is our final answer.